everyone. This is video number 2 for class number 7. So we're continuing on in chapter 3. And we started off with 3-4, and I'm still technically in 3-4 here. So the first video dealt with standard form and vertex form, and looking at the graphs of each one of those. They're all parabolas, but there's different ways that you need to approach them to find the vertex. So that's kind of the idea. So make sure you know the difference between the two. Now, it is helpful to be able to switch between the forms. So in algebra 1, we sometimes start out with standard form, and we switch to slope-intercept form. And I think that was just on quiz number 4. However, now in algebra 2, when you do a parabolas, it is helpful sometimes to go from standard to vertex and from vertex to standard. So we are going to look at doing that. So to go from standard to vertex, the first thing you have to do is find the vertex. Okay, so how do I find the vertex again? If you recall, you have to use x equals negative b over 2x. Okay, so that's going to be the first step. So x equals, and this is from the other video, so x equals opposite b, which is 8, all over 2 times 2. Remember, this is a, b, c. And that's 8 over 4, and that's 2. Now, if I plug 2 back in, I end up getting y. So plugging 2 back into that is going to give me 2 times 4, 2 squared, minus 8 times 2, plus 4. And that's 8 minus 16 plus 4. And that ends up being negative 4. Okay? So y ends up being negative 4. Once you find the vertex, that is your h and your k. Okay? So 2 is h, negative 4 is k. Now the second step is to just use, the second step would be just to use vertex form now and plug everything in. And what you want to plug in really is just the a, the h, and the k. Okay? Everything else is going to stay. So y equals a, is going to be the one up here. 2 parentheses x minus the h, which is 2 squared, plus negative 4. Also, we can just write minus 4. If you write plus negative 4, that's okay, but you've now just switched that to vertex form. Okay? When you're going from vertex form to standard form, you first want to FOIL. Okay? And the FOIL is going to be right here. So x minus 2 times x minus 2. So you're going to want to do that first. Be careful when you FOIL. You're going to get x squared minus 2x minus 2x plus 4. Remember, you get 4 terms when you FOIL. F-O-I-L. Okay? Negative 2x and negative 2x makes negative 4x. And of course, at the end, you are going to have 4 minus 3, which is 1. And voila, you are in standard. So once you FOIL, and be very careful FOIL, you will have to combine like terms. And that's it. So a little easier to go from, I think, that way from vertex to standard than it is the other way. But either or, you have to be able to go back and forth. So even as a self-check right now, if you wanted to check, you guys could start here at standard and see if you can go back up to that example. And likewise up here, start with the blue box one, which is in vertex, and see if you can get to the one that's in standard. But that sums up the notes for chapter 3-4. Okay, so moving into chapter 3-5 now. 3-5 deals with a bunch of operations with functions and basically a lot of notation. So if you've never seen functions, this boils down to a lot of notation type things, like what does it mean to do, what does it look like. All right, so I'd like to do one big example here. So if given, and we're going to go ahead and just give you a couple of functions here. So f of x equals 2x minus 7, and g of x equals 3x plus 4. Okay? And as far as that, we're going to go ahead and leave it like that. Okay? All right, so what can you do with functions? So all of the above. You literally can do a bunch. So the first thing is adding them. I'll use A for adding. So when you add two functions, we've already done this. What does this typically look like? It typically looks like f of x plus g of x. Okay? So it's probably how you're going to see it written with a plus sign in the middle. When you add functions together, you are just combining like terms, guys. So you get 2x minus 7 equals 3, oh geez, not equals. 2x minus 7 is f plus 3x plus 4. And you are just combining like terms here, so you end up with 5x minus 3. And that's it. Okay? So when you add, you do combine like terms. B, when you subtract, and it's very similar to polynomials. When you subtract, you're probably going to see subtraction in the middle, of course. And when you subtract, you have to be careful. 2x minus 7 for f. However, when you subtract g, you have to put that in parentheses because you have to subtract all of g. Okay, so be careful to use your parentheses there. So it ends up being 2x minus 7, distribute the negative. Negative 3x minus 4 is probably one of the biggest mistakes here. Now you combine like terms, so it's negative x minus 11 for that one. So don't forget to distribute the negative. Just if I was writing a little bit of notes here. Distribute the negative, and then combine like terms. Okay. So that's kind of the idea for that one. All right. The other thing you can do with these is multiply them. And when you multiply two functions, guys, it truly is just FOIL. Okay, so again, what does that look like? You'll typically see f of x times g of x. So as far as that, you have 2x minus 7 times 3x plus 4. And that ends up being FOIL. So 5, not 5, 2 times 3, that's how I check, 6. 2 times 3x is 6x squared, 2x times 3x. 2x times 4 is 8x. Negative 7 times 3x is negative 21x. And negative 7 times 4 is negative 28. Once you do that, you do need to combine like terms. You end up with negative 13x minus 28. Okay. So as far as that, if I was taking a little bit of note there, FOIL, combine like terms. Okay. So it's kind of just a different way of looking at it, more mathematically, more function notation. As far as division, you can't really divide these things. But if you're looking at division, it's going to look like f of x over g of x. And it's going to look just like 2x minus 7 all over 3x plus 4. And guys, you can't do anything there. Okay? Mathematically, if there's a plus or a minus in there, you cannot just cross off things at will. You will have to factor first and then cross off things that match. Okay, so that gets a little tricky. Normally, you can't really do anything on those. Okay, so they're just as is for the most part. Okay, now when that gets a little bit more complicated, then of course those can be broken down. But as far as a basic function, they're not. Okay. All right, and those should be all the ones you're aware of. And we did go over those, and we did polynomials, so that should be kind of a review for you. Okay, so the new stuff here. The new stuff is function composition, and this is when you put one function inside of the other. So why is this used? Well, it's used because in life, one thing isn't just perfectly straight. So like your car doesn't just go 60. You go 30, 40, you're accelerating, decelerating, stopping, going, I mean, whole 9 yards. So if you look at anything in life that moves, it's typically a composition of functions. There are a bunch of functions put together to make a function. So we are going to look at function composition. And there's a couple different ways of looking at this. So notation-wise, and make sure we see it. So first way is the little open circle. And notice that's an open circle. This is read f of g of x. Okay? And it can also be written like this. The other way, g of f of x, and that could be written like that. So again, that would be g of x, g of f of x. Kind of a mouthful. Okay, so as far as notation-wise, you could see it either way. Okay, so kind of I want to talk about both ways here. So the first way means basically I always used to teach f. The first letter that you see is kind of like the skeleton. So f. So what was my equation f? So if I flip back, f was 2x minus 7. So 2x minus 7 is basically like your skeleton. When I say skeleton, because it's Halloween coming up, right? Skeleton, I mean that's the outside function. So when you see the x, you're putting a parenthesis on that x. Because the second function that's listed is what's going into that. So now g of x is going inside of f. Okay? So now what was g? G was 3x plus 4. So now you are putting 3x plus 4 inside of that. Okay? And once you do that, the mathematics is usually pretty easy. It's either FOIL or distribute most of the time. You get 6x plus 8 minus 7, and that turns into 6x plus 1. Okay? Likewise, I could switch it around and do g of f. That would mean that you start with g. Okay? So g would be your outline, so 3x plus 4. However, you're going to say 3 blank plus 4. I used to tell students, say the word blank when you see an x. So that means there's something has to go inside of that. And just draw blank parentheses. So once you have that, oops. So once you have that, now f of x goes inside. So f of x is now going inside g. So now you go up here to f, it's 2x minus 7. So now you're putting a 2x, I guess I can use red pen instead of green. So now you are putting 2x minus 7 into that. Okay? And likewise, you have distributing. So 6x minus 21 plus 4. That ends up being 6x minus 17. Okay? But it's the process of sticking one function inside of the other. So be careful on that. Once you plug it inside, you will have to distribute and actually do some math. So basically substitute a function into the x of another, and you will have to simplify. And the simplified part is truly distribute, usually, and combine like terms. Okay, so for the most part, that's truly what you'll be doing on that as far as that. Okay? All right, so that is my short second video. I do have a third video. It's going to be short as well. But the third video is going to address chapter 3.6, which is inverses of functions. So tune in. If I can't get this video done today, I'll get it done first thing tomorrow morning for you. But this is inverses of functions. Okay? All right, guys. Thank you for bearing with me. I will see you back again for the third video.